Okay.
Okay, shall we start now? It's 1 o'clock already. First of all, welcome all participants, friends and colleagues. I can see from the name, we have a lot of new participants, to join us. You are welcome. I hope that today will be, the other day, we will have a good, webinar. And I would like, in the end, I would like to have you, to have more joy discussion or even question, ask the question, or even suggestion and recommendation for our activity, to think more about how we are going to move forward in the future. The webinar today, the moderator for the webinar today is Professor Eileen. It's from our colleague from the Mauritius. She's a first speaker on the first day. She's going to be moderator for today. I give the floor to Eileen. Yes, please, Eileen. You can take over the floor to conduct the webinar.
Thank you. Thank you, Dr. Somkiat, for the introduction. A very good afternoon to all honorable speakers and respective ladies and gentlemen. I welcome all of you to the IOC-WESTPAC Ocean Acidification Webinar Series number 3. I think this is the third series, which is the third Wednesday. So before I start the session, I wish to announce a few house rules for the webinar. This webinar will be recorded. Yeah, all audience are required to mute and off their videos during the presentations of speakers. The audience are allowed to unmute and on their video and ask questions during the Q&A session at the end of all the presentations. The audiences are also allowed to type their questions in the chat box in the Zoom application. Today, we have 3 honorable speakers from Thailand, Vietnam, and the Philippines with us to share their experience and research. Let me take the opportunity to introduce the first speaker, Dr. Suchana Chavanich. Dr. Suchana Chavanich received her PhD in zoology at University of New Hampshire, USA. In 2001, Dr. Suchana began her academic career at the Department of Marine Science, Faculty of Science, Chulalongkorn University, Thailand. At present, she is an associate professor. She has a broad base of ecological research interests that involve the study of nearshore species from tropical to polar regions. In addition, her research focuses on conservation and restoration of marine ecosystems, particularly on coral reefs. Currently, she is also the project leader of coral reef conservation in the Western Pacific under the UNESCO IOC Subcommission for the Western Pacific. Because of her work, she has received several awards and recognition, such as Sustainable Ocean Ambassador appointed by UN AFMA FAO Annex in 2019. She's also been awarded as one of the 17 Asia Power Women of Inspiration, selected by her World magazine in year 2015. Congratulations, Dr. Suchana. And without further delay, I would like to invite Dr. Suchana to present her talk today. Over to you, Dr. Suchana.
Hi, Eileen. First of all, thank you very much for the introductions. First of all, I would like to thank Vinci and Dr. Somkiat for giving me an opportunity to join this webinar. And also, thank you for allowing me to participate in an ocean acidification program of the WESTPAC in the past several years. So today, I would like to share with you all about the research on the corals and ocean acidification in the WESTPAC, particularly in Southeast Asia, on how much has been studying related to these issues. And then I will give you an examples of the study that we did on the impact of the ocean acidifications on the coral reef itself in Thailand. And at the end, I will share with you all about what we are doing now with the coral regarding try to restore them under this climate change, under this ocean acidification issues, and what factors that we should be aware of. So next slide, please. Well, these are the main co-authors of these projects, but actually we have so many people that involve, particularly the member of the reef biology research groups I didn't put their name into this, but I also would like to thank all of them. Without them, this project would not go too far. Thank you. So next slide, please. So as we all know that unfortunately coral reef around the world have been declining because of those anthropogenic activities, including the climate change and also increasing of the atmospheric CO2. And these can affect not only the fishery itself, but also the livelihoods of the person who live along the shorelines. So, and this study of actually from Peterson's and the team, they try to show the linkage between the corals, people under the high carbon CO2. So next slide, please. So as we can see here, for Southeast Asia, this is in the blue color area, we are really depending on the coral reef on the ecosystem service. But if the CO2 in the atmosphere still increase, causing the ocean acidification, what this graph show that in 2050, coral reef in Southeast Asia will have tremendous threats from these risings of the CO2 in the oceans. Next slide, please. Well, we believe that, right, that the coral have tremendous effects from the ocean acidification. But the data that I got is quite interesting. Actually, this data, I asked two of my students to help, and this is updated since yesterday. Okay, so these show the paper that have been published in the Scopus, that show in the Scopus database from 2015 to present until yesterday. So we use the keyword on coral and ocean acidification, and also coral and pH. So this is the result that we got. Well, you can see that in the past 5-6 years for Australia, they published about 23 articles, China 14, Japan 26. But for Southeast Asia, actually includes, you know, Thailand, Malaysia, Singapore, Vietnam, Philippines, Indonesia. We have 5 plus, because I know that there's 1 or 2 paper that now on the way that going to publish and include in the Scopus database. But you can see that 5-6 years, we have in Southeast Asia only 5 paper that really related to the ocean acidification and coral itself, okay? And actually this data not include the paper that published related to the reef organism, but just only the coral itself. So this means that in Southeast Asia region, we really need to work on the ocean acidification and coral research. So next, I will show you the example of the research in Thailand that we did related to the coral. In addition to the talk, previous talk from Dr. Chalermrat and Ms. Kanita in the early webinars. Okay, next slide, please. Okay, for this presentation, I will give you an example of how ocean acidification have effect on these 2 dominant coral species. One is brooding coral, Pocillopora demiconis, and the other one is spawning coral, Acropora millipora. Next slide. So to this presentation, I will show you that the effects of ocean acidification from, you know, releasing gametes to the development and settlements of the coral in each species. Next slide. So, well, when we test for the Poecilopola demiconis, for this one, since it's the brooding species, so they release planula, not the gametes. So we did collect the gamete, the planula of the Poecilopola, and then test with different pH. Control is 8.1, and then we test with a 7.9 and 7.6. So what happened is that first, it showed that when Poecilopola itself put into different pH conditions, they tend to release more larvae at the pH 7.9, but then it eventually is dropped when we put this Poecilopola into the 7.6. Next slide, please. So when we look at the spawning time, pH actually didn't have effects much on the spawning time for these Poecilopola. They still prefer to spawn at nighttime, but still the spawning rate were high at pH 7.6 compared to the normal pH 8. Is high on 7.9 compared to the control one pH 8.1. Next slide, please. So how about the effects on the settlements of the planula of this Poecilopola? When we reduce the pH, it also reduce the settlement rate of this Poecilopola too. So you can see that at 7.6 pH, the percent of the settlement rate is much lower than the control and the pH at 7.9. Next slide, please. So this shows a typical of the egg state of the larval development of Poecilopola demiconis in a controlled pH conditions. Next slide. So after we collect the larvae and let them metamorphose into different stages in different pH, what result that we found is that when pH was reduced, the planula could not complete their development. For pH 7.9, it can reach only at the 7th stage. But for pH 7.6, you could see on the red line, it can reach just only on the 2nd stage. Next slide, please. So now, we look at the Acropora is a spawning species. So we did collect the gamete of the Acropora to do some testing, looking at the effects from the pH. Next slide, please. So when we look first at the fertilization rate in different pH conditions, the results show that the pH has significant effects on the fertilization rate of Acropora. It's reduced to 60% from 95% of original fertilization rate at the normal conditions. Next slide, please. So this is a typical larval development stage of the Acroporas, okay, in a typical, in a normal condition at pH 8.1. Next slide, please. So when we reduce the pH, what we could see is that the pH made the cell abnormal or distorted. You can see that the cell is not really, real circle. It's kind of tear apart. Next slide, please. So these actually show that when we reduce pH to 7.9 for this Acropora larvae, they can still develop to the final stage, but it takes longer time. If you look at the green line, okay, it takes a little bit longer time to reach into the final stage. Not like a Poecilopola. If we recall, for Poecilopola, they cannot really complete metamorphosis at 7.9 at all. Okay, but for Acropora, they can, but it takes a longer time. But if the pH reduced to 7.6, then these cobra larvae, they cannot really complete the development. Next slide, please. So for the settlement, if pH 7.6, they definitely cannot really settle onto that pH conditions. Next slide, please. Okay, how about the effects on the adult? We test with the fragments of the cobra. And actually many studies, if you review the literature's paper, many studies have done on this stage. So what we can see is that if we put this fragment into a different pH, you could see the coral start to breach and the tissue some kind of distort. Next slide, please. So, and it's actually caused some breaching and completely die for the pH 7.6. 7.9 is not die yet, but if 7.6, then the coral start dying. Next slide, please. Okay, since coral not only rely on the photosynthesis, they also capture the food. So we test if, coral is in the lower pH, how capture rate would be. So we gave them the artemia to feed on in different pH condition. Next slide. And usually in a normal conditions, if the coral get artemia, they can be able to easily digest feed in 2.5 hours. Okay, next slide, please. So this show that actually the left column is in a normal conditions, pH 8.1. On the right column, when we give the food to a cobra at the pH 7.9, and you could see that at lower pH, they hardly capture the food. So that is quite a difference. Next slide, please. So, well, what we learned from this is that other than the climate change, ocean acidification can also make a coral breach and die. Next slide, please. So there are some studies, for example, from Guest and the team show that if the environmental condition changing slowly, coral perhaps can adapt and acclimate themselves under thermal stress. But well, not many studies have done yet on the ocean acidification adaptations and coral. So this is the area that will be interesting for further investigations. And Tuan and Patrick, the next two speakers, will show you more on the ocean acidification and coral in Vietnam and Philippines. Next slide, please. So actually this paper we published 2 years ago, 2019, with the support from IAEA, showing how Indian Ocean and Southeast Asia are dealing with or will be dealing with the ocean acidification on the coral reef in the regions. And we can see here is to deal with the ocean acidification and to help the policymaker for decision-making process. Several components need to be evaluated and understanding. For example, the climate policy, education, policy coherence, research activity, adaptive capacity for reef depending economic sectors, and local management. It is interesting to see this as an example is that in this picture, it shows that international policy get very high alignment. But when we look at the research and training and also adaptive capacity of reef depending sector, they have quite a low alignments. So actually, this is not surprise that if you recall the first slide that I showed you about the number of the paper that related to OA and the coral, the numbers of the paper in the region is quite low in Southeast Asia. So this means that we really need to encourage more study to fill the gap, to make sure that more data available for those policymakers and decision makers. Next slide, please. So, well, how are we gonna tackle with these ocean acidifications? Many activities have been done, particularly on a coral restoration, coral rehabilitation, but actually one thing that I would like to point here is that coral restoration rehabilitation is not for solving the OA directly, but to solve with the problem of the coral declining. Next slide, please. Well, you probably know this green guy, the hut, right? But one thing that I would like to point here is that when we talk about restoration, we usually emphasize on the number of the coral that we will get from the restoration. But in the reality, we also need to consider those coral that we produce have adaptive capacity to change with the change of the climate or a change of the ocean acidification or not. And as you may heard about super coral, right? How we can make coral to be a green man or a hawk is very important to be sure that those coral that we produce can survive in those environmental change. In this case is OA. Next slide, please. So can we do it? It is quite a challenge. But now we know that, the technology is quite advanced. We can do IVF cryopreservations for the corals, but why not? How we can adapt, a coral itself to be more tolerant to the environmental change. Next slide. Well, what next is we know the effects of the OA on the coral. We know how to restore the corals, but do not forget that those coral restoration techniques have to be adjusted or advanced continuously to make sure that we not only, organize the wedding ceremonies for coral, but we want to make sure that the baby that come out are the hawk baby, a super coral baby. Next slide, please. Yep, that probably the end of my talk. I would like to thank some many organization, funding agency for support this project. This is it has been quite a long for us to carry these projects. Thank you very much.
Thank you, Dr. Suchana, for the interesting talk. We will come back to you on the Q&A after all speakers have presented their talks, okay? Please stay on with us. We'll come back to you, all right? Now let us move to the second speaker, Mr. Vo Tran Tuan Lin. A brief introduction of Mr. Vo Tran Tuan Lin. He is a young researcher from the Institute of Oceanography, Vietnam Academy Science Technology, VAST. He has been involved in the ocean acidification research network since 2015. Since then, Vo Tran Tuan Lin has tried to learn and improve his knowledge to become one of the focal points in this field in Vietnam. The presentation today can be considered to be the results of one of his initial studies on ocean acidification. He hoped to receive new sharing and suggestion from all of us. Without further ado, let us hear from Mr. Vo Tran Tuan Lin. Over to you, Lin. Okay, I think Vo Tran Tuan Lin, he's having some technical difficulty. Can we move on to the third speaker, and we'll come back to you in a short while. Let's have Dr. Patrick Chabaitan. Dr. Patrick, Dr. Patrick. Yeah, Dr. Patrick is an associate professor at the Marine Science Institute. He has University of Philippines. He has completed his PhD in marine science at the University of Rukos, Japan, and was a postdoctoral fellow at the National University of Singapore. Dr. Patrick's research interests are on community ecology, restoration ecology, giant clam conservation. Without further ado, let us have listen to Dr. Patrick now. Patrick, over to
Good
you.
afternoon, everyone. I am Patrick Cabaitan, a coral reef ecologist from the Marine Science Institute of the University of the Philippines. I would like to share with you the findings of our project that aims to examine the influence of acidification and associated stressors on coral reef resources in the Philippines. This project was made possible by a collaboration with my colleagues and students. The reef resources or reef organisms we are studying are ecologically and economically important. They help maintain the health of coral reef ecosystems and provide ecosystem services. Coral reefs are one of the most biodiverse and productive ecosystems on Earth. Corals and other benthic organisms like sponges, algae, and giant clams provide shelter and food to other reef organisms, including fishes. These fishes in turn provide food to humans. In addition, because of the fascinating colors and forms of plants and animals in coral reefs, they attract tourists and provide ecosystem services. Many of our reefs are under threat. Coral reefs that are exposed to disturbances such as destructive fishing and runoff from land are in rapid decline and may not be able to recover from disturbances quickly, especially if these disturbances are frequently occurring. On the other hand, disturbances such as ocean warming usually occur during warm months. Ocean warming can cause coral communities to bleach and die. However, we still do not know much about how the different members of reef communities will respond to changing seawater pH brought about by eutrophication, particularly near fish mariculture sites. How do reef communities maintain their health and recover from disturbances? Recovery starts with reproduction. Most of the reef communities reproduce by spawning or by releasing millions of gametes into the water column, which allows fertilization of eggs. Fertilized eggs then undergo development for a few days until they become well-developed larvae. Once larvae are ready to settle, they look for a hard and suitable substrate to attach to and grow. While gametes or larvae are in the water column, they are they may be carried to another reef or they may just stay on the reef where coral spawning occurs. Hence, spawning will initiate the recovery of degraded reefs not just on the reef sites where spawning occurs, but also of degraded reef communities in adjacent reefs. For recovery to happen, the quality of water in these reefs should be clean and conducive to fertilization, development, and growth of larvae. If the water surrounding these reefs are turbid, polluted, warmer than the normal temperature, or acidified, larvae will not be able to survive and settle onto a reef substrate. Coral larvae and larvae of other invertebrates settle onto hard and stable reef substrates such as the coralline algae. However, many of the degraded coral reefs are covered with fleshy macroalgae that are proliferating because of the decline in the abundance of herbivorous fishes that feed on macroalgae. The decline of these fishes is mainly caused by overfishing. Another reason why fleshy macroalgae are becoming abundant on degraded reefs is the introduction of excess nutrients into the reefs, which makes waters in the reefs all acidic. Aside from corals and fish, there are other components or organisms that help maintain the health of reefs. Filter feeders such as giant clams and sponges help filter and clean the waters. Macroalgae and seagrass also serve as food and shelter for other marine organisms. Sea cucumbers and top shells are detritivores and grazers that control the proliferation of micro and macroalgae. Reef biofilm are also essential in the settlement and recruitment of larvae of various reef animals. So when we want to examine the impacts of disturbances on coral reefs, we need to study not just one organism. It's important to study various organisms with different functions in the reef to be able to understand better how reef communities maintain their health. In this project, we conducted field observations to select representative reef organisms that are likely to be impacted by ocean acidification and other stressors. We also conducted experiments in the laboratory to isolate and test the effect of certain parameters on reef organisms. For instance, we tested the effect of ocean warming and acidification on giant clams and other reef organisms presented in the previous slide. One of our main study sites are in Bolinao, northwestern Philippines. We established study sites with varying distance from a fish farm to test whether nutrient influence from a fish farm would impact the water quality of the adjacent reef sites that would consequently affect reef communities. Why would fish farms generate nutrient effluents? In this location, milkfish are being farmed for food. Milkfish are provided with feeds with high nutrient content. Oftentimes, milkfish are not able to consume all the feeds that are provided to them. Excess feeds that are not consumed by the fish would cause the nutrient level in the waters to increase, consequently making the waters near the fish farm more turbid and acidic compared to sites far from fish farms, which usually have clearer water. One of the experiments we conducted was to examine the effects of fish farm effluents on the benthos and recruitment of corals in reefs with varying distances from the fish farm. In this study, we put recruitment tiles on reefs with increasing distances from the fish farm and examined the types of organisms that settled and attached into the tiles. Remember that reef site 1 is more turbid and acidic compared to reef site 3. We found that more fleshy organisms such as ascidians, sponges, and algae attached onto the tiles placed near the fish farm, a reef site with a more acidic water. In contrast, recruitment tiles placed far from the fish farm had more calcifying organisms such as coralline algae. Higher cover of coralline algae leads to higher coral recruitment, which is good for the recovery of degraded coral communities. Coral recruitment in the reef site near the fish farm is hindered by the proliferation of fleshy macroalgae, ascidians, and sponges brought about by the deterioration of water quality and acidification due to excess nutrients from fish farming. At the three reef sites with varying distances from the fish farm, we also examined the amounts of biofilm that developed and types of microbiome that settled onto artificial substrates. For this experiment, we used microscope slides as artificial substrates, so it would be easier to scrape off from the substrate and analyze the biofilm. The graph at the left side shows a selected list of possible settlement-inducing bacteria as identified in past studies. The x-axis shows data collected in different sites with varying distances from the fish farm, 7 and 15 days after deployment of artificial substrates. We found that there were more abundant settlement-inducing bacteria at the site far from the fish farm. This supports the data collected on coral recruitment wherein higher recruitment of corals was observed at the site far from the fish farm. We also examined the response of giant clams, a representative of the bivalve mollusks, when transferred to the three reef sites with varying distances from the fish farm. The mantle of the giant clams at the reef site nearest to the fish farm had retracted and showed some discoloration or mild bleaching, a sign of poor health likely due to reduced activity of its symbionts and hampered filtering capacity brought about by the acidified waters and high nutrient levels. The same response was exhibited by the juvenile giant clams when exposed to an experiment in a laboratory with increased temperature and low pH. These findings imply that shell or clam fisheries and aquaculture will be compromised and damaged when set up in a acidified water. In addition, giant clams are one of the filter feeders in the reef. The filtering capacity of giant clams may be impaired or damaged when exposed to ocean warming and acidification, as shown in both laboratory experiments using juvenile clams and in the field experiments using adult clams. As mentioned in the previous slide, more sponges were observed on recruitment tiles placed near the fish farm with more acidic waters. However, not all sponges are resilient to ocean acidification. When we conducted experiments in a laboratory, sponges with calcareous skeletal elements perform poorly, whereas sponges with glass-like skeletal elements perform very well. This difference has implications in the filtering capacity and proliferation of sponges when exposed to acidic water. Laboratory experiments also revealed surface erosion and slower growth of the calcifying macroalgae sporulton when exposed to a more acidic water. In contrast, lower pH did not affect the growth of fleshy macroalgae Capophycus striatus. This result supports the findings of the field experiment wherein fleshy macroalgae became abundant in reef sites with water quality deteriorating or becoming acidic. Most studies in the past examined the influence of elevated temperature and lower pH on the physiology of reef organisms. Very limited study has been done to examine the influence of changing temperatures and pH in the interaction of reef organisms, which are essential in the maintenance of reef health. Here, we exposed juveniles of sea cucumber and top shells to different ocean warming and acidification treatments and examined their grazing activities. Increase in temperature and lower pH affected the grazing activities of sea cucumbers and top shells in hatchery experiments. On the other hand, the changes in pH and temperature did not affect marine biofilm periphyton, the food material that were being grazed by sea cucumber and top shells. This finding has implications on the grazing capacity of these organisms when a reef is exposed to warming, ocean warming, and acidification, as these detritivores and grazers control the proliferation of micro and macroalgae that are essential to the settlement and recruitment of other reef organisms. In summary, our results demonstrated that the effects of ocean warming and acidification on various reef organisms are complex, which underlines the importance of considering responses from different members of an ecosystem to better understand the influence of stressors on trophic interactions, coral recruitment, dynamics of reef communities, and reef health. Our findings also emphasized the implications of the negative effect of ocean warming and the acidification of the many vital ecosystem services that are provided by coral reefs. I would like to end this talk by thanking Picard of the Department of Science and Technology of the Philippines for the continuous support on research. This project was made successful by a collaboration of many researchers and students. And I would like to thank IOC-WESTPAC for the opportunity to share the findings of our research. Thank you for listening.
Thank you, Patrick. Thank you, Patrick, for your interesting talk. Please stay on with us. We will have Q&A session with you at the end of the session. Now we would like to invite back our second speaker, Mr. Vo Tran Tuan Lin. Can you please try and see whether you are able to hear you or not, Lin?
Do you know me?
Yes, good. We can hear you now.
Okay, I'm so sorry.
Great. We can hear you now. Yeah.
I don't know what. Okay. But wait.
Please do your presentation. Thank you.
Okay. Okay. Wait. You see it?
Yes, we can see your yes. Yeah, great. Yeah.
Okay, so sorry. It's a technical error. I don't know why, but I did nothing, but it's worked now. Okay. Sorry, Patrick, I cannot penetrate to your presentation. Maybe we will talk later. Okay, today I will talk about a new data from our country, our institute. It's really new data for ocean acidification research. Okay, the rationale of this project, of this report is on all of the emerging concerns about acidification. I won't talk anymore about it. But very few research on these issues in Vietnam. And actually we have some monitoring data of pH, salinity, alkalinity, but it is not so reliable and comparable to our network. So we started, and this is one of the initial data. Okay, the objectives of our project is to present an overview of acidification situation of coral reef of South Vietnam. This is first data, so we don't have anything to compare. It's just very new, and it's like a background data and baseline data. And the second objective is initial assess the positive influence of calcification of copra corals with two species of copra. Yeah, this is the area that we do. And total, we do just the south water of Vietnam Sea. You can see here. Yeah, this is the site. We do temperature and salinity in situ measures, and other with following the WESTPAC SOP. And you can see the sites here, the area here, and one of our sites is Spatial here. It's very offshore, very far. Yeah. And we develop a new methods, like and we try to measure the growth of coral as we mark it in the sea. Let it continue naturally grow, then sample them. You can see here, we mark here and then let it in the sea, under sea, and we measure the new length. Okay, we can see the process is follow. The coral branches will measure at mark with plastic scoring at 5 centimeter length from the tip, and healthy branches should be straight and without sign of branching or sprouting. After 1 month, the mark branch were collected and measured the new length, and we calculate the growth in length of coral. And after measure the growth in length, we match the coral, then dissolve in the solution, acid solution, and then we titrate the calcium content and calculated the carbonate content. And finally, the calcification rate was calculated by subtraction the weight of calcium carbonate at the sampling from the initiation and divided by the number of days. Okay, and we have some results like this. For offshore reef, we have some offshore reef here. We can here Cont Island. It's not only like offshore, but like very less influence of the fresh water. And we got like here we have this area, yeah, and part of this. You can see that, and as this, you can see as this area, the offshore area here, the pH and omega values were quite low, and other areas, offshore area, is seen better for coral and calcifier, as own value in this area were higher than 3. Yeah, this table. You can see the mean value of parameter of offshore coral reefs. You can see here in this area, the omega value is very good, and the pH a little bit higher than in the Southwest area. Yeah, and it can be explained that in the south offshore area, the values only lower than 3. And it would make the organism stretch. It might be because of the influence of Mekong Gulf of Thailand water mass with high temperature, low salinity, and pH. But I don't know. We have very thin, very less data. So we need more data to be confirmed about this. And also among Scary and Fukui Islands. Yeah, you can see here. This value is very good, higher than 4, and this is ideal for coral growth and recruitment. And it is noted that these sites are in a strong upwelling area. Maybe this will include it, but I don't know. I don't know yet. Very few data, so. Maybe we need more research to confirm this. And for the coastal coral reef, we do 2 times in northeast monsoon, late northeast monsoon, and early southwest monsoon. And same as offshore data, the value were almost identical. High pH and omega value at the central area here. B and C is a little bit higher and lower at the southern area here. Yeah, well, you can see here. And in terms of seasonal variation, the late northeast monsoon have lower pH and omega value than during the earlier southwest monsoon. Yeah, you can see this figure. Compared to other coral reef dominated water, with the omega is around 3.5. So the omega value here in the center of Vietnam, Nha Trang and Ninh Thuận were almost similar, while the south is a bit lower. It seems that the environmental conditions in central waters, both coastal and offshore, were much better in terms of acidification. Given the fact that there are many big healthy coral reefs in Cont and Phu Quoc, yeah, we have a lot of publication here, and I think most of you know this area have very good coral reefs, and with high resilience and rehabilitation. So we need to research more on the comprehensive environmental conditions and the accumulated impact on resilience of marine life in the future. That we need more. We need more data, both ocean acidification and accumulated impacts. Yeah, for the temporal change in time, we can see the pH and omega value change from 2.84 to 3.19 for omega and 7.91 to 8.01 for pH, but actually no significant trend during the period from February 2019 to May 2020. Yeah, and you can see the coral growth rate in length. It's also, there's not a clear trend, but generally the Acobra muricata grew much better than Acobra robusta during this study, except only 1 month. Only a remarkable point that in December 2018, in 44 days, muricata did not grow. Yeah, you can see here. While robusta had good growth rate, so 0.104 millimeter per day. Yeah. That is, we use questions to try to analyze the relationship, but actually not at all, not so significant relationship. Only we have like a relationship between carbonate and omega value. Here you can see like the percentage of carbonate with the omega values. And the coral calcification and percentage of, yeah, you can see data from 2 periods, from 3 March to April 2020 and April to May 2020. We estimate the calcification of 2 coral species, and besides the carbonate content was also calculated to estimate the density of coral. It was a strange result that when coral had better calcification rate, it means it grow more, and the carbonate content become lower, mean lower density of coral. You can see this figure, like when they high this and then they will low at density. Yeah, and we have some like conclusions. It's like not conclusion, but yeah, something like that. The coral reefs and center side grow better in acidification situation with the highest pH at Fukui area and highest omega in Benteng area among offshore reef, and highest pH and omega value in Nha Trang among near shore reefs, coastal reefs. Yeah. On the second is on omega value of offshore southern reefs were lower than 3. And the coastal reef at Phuket was somewhat better, but the mean value of omega was still below the threshold. The temperature variation of pH and omega value at the study site in Minton did not show the significant trend. On top display is a strong upwelling area. Yet, let me talk a little about this, because actually in the first, our approach is, you know, this area is in the strong upwelling area, and it's assumed that in this period of upwelling, the pH will change very high, like very change trend very significant. But when we set the study site here, and it did not show the significant trend. Maybe like it's not upwelling at this time, or we did not test the place, the right place. And the growth rate in the length of coral in this research did not seem to have a clear trend, neither in relationship to pH nor omega addition. And this research could not assess any clear impact from acidification-related parameter to coral calcification and density. But we did develop and try new methods for such assessment, and then we gave some suggestions for future improvement. Actually, this is one of, we have 2 papers on ocean acidification in Vietnam, and if you want more further detail and discussion, yeah, you can assess and see the paper and maybe give the comment to the paper. Yeah, I put this idea. Okay, thank you for attention, and please give more some suggestion.
Okay, thank you very much. Thank you very much, Mr. Vo Tran Tuan Lin. Thank you very much. Now we have reached the Q&A session. I would like to ask IOC-WESTPAC to stop sharing. I would like to have all the audience to on their video, so we can have some sort of like a discussion. Yes, that's good. Thank you very much. And I have a few questions here. For those audience, I would encourage all of you to on your video, so all of us can feel like we are having face-to-face conversation. All right. Okay, I have a few questions here in the chat box. Yeah, let's go to the chat box first before I open up to the audience. Yeah, I have a question from Matini Yucharon. I think Dr. Apple have actually answered, but I would like to ask again, because it will be good to benefit all the audience here. Yeah, the question sounds: in case of coral larva development under low pH, is there any abnormal sign apart from low settlement rate? For example, any eroding carbonate or bleach, like it usually happens with adult. Dr. Apple?
Hi, yeah, thank you, Dr. Metini, for the question. It's very, excellent question. Actually, when we look at the development stage, we look from a planula. So actually, for the Poecilopola itself, we don't really see any abnormal sign much. But for the Acropora, we did quite see many different abnormal shapes. This is actually different kind of shape that, showing the sign of abnormal. But unfortunately, I show you just only a couple, abnormal shape. But actually, we found more than 5-6 abnormal shapes. Thank you.
Thank you. Another question also to you from John Patrick Mecca. Have you produced or developed coral species that has tolerance to low pH or ocean acidification? Dr. Apple.
Well, thank you very much for this question. Actually, it's probably my, our group's next task force. But now we're working on try to raise the coral in a high temperature, but we're not trying it for the OA condition. So very good suggestion. We will try next time. Thank you.
Thank you. Thank you. So the next question on the chat box is also from Dr. Matini to Lin. Yeah? Regarding the pH variation from year 2019 to year 2020, where was the place that you sampled? Is that the study site close to Thailand?
Actually, it's in the central of Vietnam. It's not close to Thailand. It's very far. It's central of Vietnam. Can I show the map here to show it?
Okay. All right. Thank you.
Yeah, it's.
Oh, okay, you want to? Okay, yeah.
Yeah. This here. It's a beach area. It's very far. Yeah. Okay.
All right. Okay, the next one is question to Patrick. How far is the distance of Site 3 from site 1 in your field experiment?
The distance is around 10 kilometers. That's from site 1 to site 3.
In terms of salinity, is there a lot of difference
In terms
between
of salinity, no
the
difference.
furthest and the nearest site to the fish cage?
In terms of salinity, they have the same salinity levels, just the pH.
Okay, all right, thank you. So now we would have another question from Apple. In view of breeding corals for resilience to ocean acidification or warming, have you noticed any transgeneration tolerance to OA or warming in your long-term coral restoration project? Basically, if they were sort of trained to be through physiological stronger in captivity, do this strength get transferred to the next generation? Apple, please.
Wow, thank you very much. A very, very good question. Actually, we would like to see too, but unfortunately, right now, our coral is still in a not mature state. We have to wait, I think, couple more years. Now it's reached probably 3 or 4 years, and if they reach 5 years, and then they can be reproduced, spawning, then we will be able to see whether the next generation, have this kind of tolerance. The same as the parents' colony or not. Thank you for the question. Have to wait for 2 more years, okay?
Yeah, I think that is also a very good question, because sometimes the gene trait, transferring from the broodstock that has been acclimatized prior to breeding, it will be good also for the next generation. I think that is a good suggestion for something for you to do, Apple, right? Okay, the next question will be for Lynn. Any change in total alkalinity in situ? Is it possible to apply alkalinity anomaly method alongside your new method?
Actually, we didn't measure the alkalinity in situ. We titrate in lab. So I think we didn't do any just apply alkalinity abnormally. Yeah. So we
maybe something you can look into, for your research, to add on, I don't know, something you might want to consider.
Yeah, no, actually, I didn't. Actually, I did. Alkalinity is not so not abnormally. No, I don't think it is possible to apply alkalinity. Yeah, I don't think so.
Okay, thank you. Now I would like to open the Q&A to the floor, to all the audience that has on your screen. Those who wants to ask question directly, please unmute yourself and feel free to ask. Any question from the floor?
Eileen?
Yes, Malo. Yes, please.
Just to follow up on Tuan's response on alkalinity, I think if there's a freshwater influence, it would be good to also look at alkalinity. Because
okay,
you can
good. Any other comments or questions from the floor that you want to raise? Please just unmute yourself, because my screen can only see 30 participants. I have a question for Apple, right? In your opinion, which is more harmful to coral reefs, bleaching or low pH? In your professional opinion.
Wow, thank you. Well, I think based of my knowledge and experience, you mean between bleaching, right? And I think bleaching is much worse, because it can come from several factors, not just only temperature, right, but pollutions and those several other additional factors that make it worse than the OA. Okay.
Okay, thank you. And I have also one question for Lane.
Yeah.
Regarding your opinion also. Does the physiological responses of corals reversible in your experiment? Meaning, can the corals recover when the pH has been improved?
Don't get the point. Again, please. Again, please, Eileen. Hello.
Yes, yes, I can hear you. Yes.
Yeah. Can you, can you ask me again? I didn't get the point.
Okay, yes, yes. Because you did, I just want to know, in your opinion, you know, there's no wrong or right answer on this. In your opinion, does the physiological responses of corals consider reversible? Can it return back to its original condition if the pH of the environment has improved?
For my research, I'm not sure yet because actually we didn't see any like significant trends. But I think yeah, if case improve, I think coral can be better again. I think so. My opinion.
Okay, good, good. Most of us hope that it can go back to its original when the ocean gets better. You know, I have a question for Patrick. Well, yeah, Patrick. Okay, in your experiment, yeah, will the light intensity of the different reef or site study play a role? Because you're just talking about the temperature and also the OA. But I'm just wondering, because of your different sites, one is very close to the fish cage and one is a very clear water reef. Will light intensity affect the growth and survival of the coral recruitment and also the giant clam survival in your experiment?
Yeah. In general, light would affect the physiology of corals. And also this depends on the species of corals. There are corals that can thrive in environment that have low light levels. But if you do transplantation, like if you transfer corals that came from a reef with a high light level and transfer it in a low light level environment, that would be detrimental to that particular species. So now we also conducted other experiments on light levels, and we found out that different light levels, especially light at night, can collapse or delay gametogenesis in corals and spawning. So we've shown that we've done that particular experiment. And maybe to add to the answers of the previous speakers, referring to your number one question to Apple, yes, temperature. We're seeing now that temperature is more impactful than pH. But what's not good about pH, the impact of pH, is that it's not obvious when you look at reefs unless you look at samples under the microscope or bring them to the lab. Now that's the one of the important things to really consider. Uh, so that's why it might be, although temperature is more impactful, we do not know if pH in the long run can also have a greater impact than pH. Although, than temperature. Although in most experiments we're seeing that temperature is more can elicit more negative response from corals. Now about number two question, there are some long-term studies. You can see that reefs in a more acidic environment, long-term data, you can see that sometimes they increase their growth rate, sometimes they reduce, and then sometimes they increase. So that shows that perhaps they can adapt to certain environmental changes. Although when it reaches beyond their capacity, corals may also die.
Yeah, yeah, Patrick, thank you very much for your great answers and explanation. I know sometimes what been conducted in the lab can be very different when you do the similar experiment in the field, you know, because when they're out in the field, there will be influence of multi-stressor compared to in the lab, you know, we are more under control. I have another question for you also, Patrick. Yeah. Are there potential organisms that can be focused to play a more significant role in establishing the reefs and providing ecosystem services in a low pH reef? Because you were talking about the responses of different various kind of marine organisms over the ecosystems, reef ecosystems. I'm just wondering, is there any potential organism that can be picked as you know, what Suchana say, you know, be categorized it as the Hulk, incredible Hulk, for to play a major role, you know, to establish and providing the ecosystem services in a low pH reef? I mean, from your opinion, what would be the ideal candidate?
From the many experiments we conducted, in general, organisms that are not forming calcium carbonate are able to perform normally or perform better than other organisms that are forming calcium carbonate. So, for instance, sea cucumber. So that means if there's a continuous decrease in pH in some reef, the communities in that area might change. I'm referring to the assemblage. So we know that different organisms would respond to different environmental changes. But again, if there's a certain environment that will prevail in a particular habitat, organisms will adjust and adapt, and that means we'll see other type of assemblage depending on the environmental condition that will be prevailing in that area.
Okay, thank you, Patrick. Thank you, Patrick. And I have a question to all speakers. Yeah, I have a question to all speakers. Yeah, but I will call one by one to answer. The question is, how do this research knowledge of yours, yeah, all of you have excellent research and you have generated very good research knowledge. Yes, before I ask the question, Lynn, you have a question. You want to answer something, right, Lynn? Sorry.
Yeah. I want to ask Patrick a bit.
Oh, Patrick. Okay, good.
Actually, I was concerned about like temperature and pH with coral. That's why I set my study site in a strong upwelling area, and I didn't follow Patrick's presentation, but I have just listened that you said that the temperature is more impactful to the coral reef than pH. Is this that, Patrick? Hello?
Yeah, Patrick.
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 And how do you think about the situation that like in upwelling period, when the temperature is lower, which is better for coral, right? And the pH is also lower, but it's not good for coral, is it? So do you have any experience about these situations when the temperature lower and the pH also lower?
My only experience is on the lab experiments. So in some corals, we noticed that they do not respond to low pH, but they respond to high temperature.
Yeah.
There are also corals that get eroded because of low pH treatment. So perhaps in your site, have you looked at like the skeleton of corals in the upwelling site? Maybe the microstructure of those corals have experienced some erosion. You can check that one. And also remember that corals, some corals could not live in or thrive in cold temperature.
Yeah.
Yeah, so that may also be cause a negative response to corals in your site.
Okay. 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 You know already. I'm not a coral expert, so I will suggest this issue to the expert. Okay. Thank you, Patrick.
Okay, thank you, Lynn, and thank you, Patrick. Okay, now back to my question, all right? Back to my question. How do this research knowledge of yours, yeah, all of you have done excellent research. This research knowledge of yours be used or shared with the general public to overcome or at least be used for mitigation or manage the reef of your country? Yeah, let us start with Apple. You have done so well, I want to listen from your experience,
Oh.
Yeah.
The lady first, huh?
Yeah, ladies first. Yes, ladies first.
Well, as a very good question, and as I did, present on my last slide related to policy making process, those things. And if you recall my earlier slide too, in terms of the publications related to the coral and ocean acidification in Southeast Asia, and what I can see that there is the gap. Even though my work, I had done some very work, but I don't think that, we can work alone. We need to be like a group to work and to help to boost up, the data, because policy maker, they need a data. If you saw those list number of the paper, if I were a policy maker, I probably would not be able to make a decision whether OA is important or not important, because there's only 5 papers in Southeast Asia, how you could make a decision. And I think we need to, get and work together more. And I think WESTPAC is a very nice platform to boost up this research and to fill in the gap and to send a message to policy maker or manager. Thank you.
Thank you, Suchana. Thank you. Very wise advice, from you. Thank you very much. Lynn, let's hear from you. How do you want to use your knowledge to help Vietnam?
It's too difficult question for me. Actually, I told you already. It is very, very close data, very immature data from my country.
You are the future. You are the future. Young generation. You are the future. So we want to hear your ideas.
Yeah, okay. Actually, our research is like give baseline data, like give very some baseline data for further research, if any. And actually, we are trying to raise the awareness, to raise like Achen said, that we need more data, we need more idea, we need something, we need more evidence to talk about the science, the scientists and the policy maker. So that's why this is very like first brick on the wall. So yeah, that's I think that's the importance role of this study. And for future plan, we need more. We will do some more research related to and expand this data, something like that. That's my hope.
Yeah, good. Like what Apple say, publish more, more than 5 papers to convince your policy maker that this is an issue that we have to address, right?
Yeah. Okay. At least I have published the baseline data of Vietnam already. Actually, we have another paper about the baseline data of acidification in Vietnam.
Thank you, Lynn. Now, we would like to hear from Patrick. What's your wise advice here for all of us? Your advice for the Philippines also.
Okay. Yeah, one of the most challenging part in research, especially once we have the data, is how we relate this to or share this with people, the public. For this, mainly we have this dialogue or discussion with a government agency called Climate Change Commission in the Philippines. So that's where we mainly share our data. And we also conduct a public forum with different towns. We share our results, and we hope to also extend this information to elementary and high school by giving webinars and making like primer about ocean acidification and its impact to the environment. I think that's
Yeah,
all.
that is very interesting. Yeah, there is something similar we are doing also, starting sharing the ocean science information to the school children, you know. Yeah, that is thank you very much, Patrick, for your sharing, you know, on how do you share your science knowledge to the public. I would like to ask the audience, is there any more final rounds of questions that you would like to pose to all our three honorable speakers? Yes, Somkiat.
Okay, thank you very much, Eileen. I have the question and then the other two recommendations. The first, I would like to respond to Lynn asking about those kind of the upwelling, impact of the upwelling to the coral. I think there are quite a number of the publication, There are study on the upwelling intrusion of the deep water on the to the coral reef, study the impact, because of this upwelling, there are not only just low pH, we also have the low oxygen as well, high nutrient and low temperature is a combination that you can find some publication, even study in the South China Sea, right? And my second is a recommendation, because of today we have been listening to a lot of three people expert on the coral and some experimental also such as working on the pH or acidity of the sea waters. I just try to remind here because of as we know that the pH is very it's very tricky measurement of the pH because now the global community working on ocean acidification, they try to make the good method to get a very accurate data for the pH in the field. And then if I would like to remind us, our experiment study, we also have to keep in mind that our measurement in the lab also should be more or less, resolution, should be good enough to be, can apply our work from the lab to the field. As Eileen already mentioned in early, of her suggestion. And then that is a recommendation. And the last one, I would like to ask, not to the three of you, and also including I saw the name of participant, a lot of expert on the coral in our webinar today. I think, because the coral we know is very important. We are concerning the impact of the OA. But I would like to hear from you that what do you think that, what is the future of our coral reef community, to work on or to do the research to generate data that the policy people needed to make the decision at Apple. Suggestion, what is the gap, for the coral reef community? What will we still missing or we still need, that kind of data, what kind of data or what kind of study we needed. I would like to ask three of you, including, if other experts in the forum I just would like to make some kind of suggestion also, I think it's welcome. We can think about, the future work on in field of the coral with the ocean acidification. Yeah.
Okay, thank you, Somkiat. So now he has one question for the speakers and also the audience. Let us now start with Patrick first. Giving Apple a break.
Yeah. Okay. Most of the research on impacts or effects of acidification on corals is usually just short term, and most of those are in laboratory setup, hatchery setup. I mean that's very good because we will have basic information on the impacts of acidification. But what's more challenging is to really look at the corals in the field. So that's why it would be good to collect cores in different sites to really look at long-term effects of acidification. And most projects only run short term, like 1 year, 2 years, 3 years. But perhaps the impacts of ocean acidification might be obvious in longer term. So that's why there should be a program that should be established to monitor that response to ocean acidification in different sites or regions with different potentially different acidification levels.
Yeah, thank you, Patrick. Can I hear your wish list, how to fill the gaps, from Suchana, Apple? What are the additional things you feel should be done?
Okay, I thought that I'm gonna be last person.
No.
Actually, as a scientist, you can see that I totally agree with Patrick, because OA in the real world now, it's not really happened yet. So a lot of things, is depend on the laboratory. It depend on the predictions. But I would like to let you, look on the other hand for the policymaker. For the policymaker, actually, the data that they want is that how it's going to have a real impact. So if we can show, that there is impact going on right now, they would buy it. But in the reality, we don't want that impact to be happen, right? Or to happen, because once it's happened, then we're not going to be able to reverse the ecosystem back. So I think the data in a scientist side, yeah, still a lot of gap, particular in the field. But for the policy maker, I think the data that they want is that it's real, it's happened, and the impact is real. But unfortunately, we could not really wait until it's happened. So that is still we need to work more on, how we can communicate and deliver the data to the policymaker.
Yeah, thank you, Apple. Very, very true. Can we hear now from Lynn? Lynn, are you still around, Lynn?
Yeah, I'm here.
Yes. Yeah, can we hear your what do you wish, that what more do you wish to do?
Yeah, I'm thinking what I'm wishing. Actually, I wish a lot.
You wish a lot, yeah. Lindsay is here, you better tell what you wish so he can all jot it down. And this is a recorded session,
Just read a comment from Israel. Yeah, and I'm thinking about. I wish that like our data from ocean acidification, like how can we link to the ecosystem and how can we link to the livelihood of the community, like in real world, in real world, not in the lab. So like it's like you can more easily persuade the policymaker to make it real. It's not it's only in the lab now. Also from that's some wishing. Yeah.
Yeah, thank you, Lynn. I would like to invite speakers from the audience. Yeah, Isara, I know you put in some chat note in the chat box. I would like to, can you on your video and tell us your idea?
Thank you, Madam.
Thank you.
Is my sound clear?
Good to have you
normally
here.
I'm in the fishery side. I'm not oceanographer, so that when you talk about the decision maker in terms of the policy and decision, you have to show them the impact. And the most important impact to policymaker is the livelihood of the fisher or the coastal community. If you can link with the climate change, the coral reef impact, sound is more. So I would suggest you may need to collaborate with the manager, coastal manager, or normally we work with socio-economists in order to study on the impact of some fishing activity to ecosystem and ecosystem service as well. That I would like to suggest you expand the study to the community level. Thank you, Madam.
Yes,
thank you, everyone.
Yes, thank you, Isara. Thank you very much. This is a very good suggestion. And in fact, I have to inform you, IOC-WESTPAC is already moving towards that direction. We have some initiative to move towards that direction to link the impact, because you are so right that without knowing the impact, you would not trigger the interest of the policy makers. look more seriously into this ocean acidification. Yeah, so right. I would like Wingzi, I will call you later. You hold on. I would like two volunteers from the audience to give their opinion. Any volunteers? If not, can I hear from Lalita? Lalita, you look so comfortable there. I want you to give me, say something. Please, yes. How are
Hi.
you?
Good afternoon,
ดีแม
everyone.
น
สวัสดีค่ะ
สวัสดีครับ
Uh, uh, actually, I am sorry that I missed the Susina's talk because of I have to attend another room. But I mean, I have read for the publication of your before, so I just guess from the questions. Actually, I don't know what I should talk about.
Your wish list. What would you want to see happening
Okay.
with this group of OA experts here?
Okay. Actually, I mean, I really happy to see that to be honest, I'm not working alone because of I can have a talk or meet people that they are not few people, but there are many people that working on the ocean acidification because of as Susana and everyone said about that we need a big pictures like the information of many places about the pH or the changing or the physical data from many places, and if everyone collect the data and bring them together so we can make big pictures even for now and for the future. And actually for me myself, I more focus on the coral bleaching and the coral and the ocean temperatures. And so far, I think I'm working on the like a small window, and if when I have a chance to talk or join the communities, so I open my eyes and like what do you have? Open my eye and see more information, and that like help me to compare what I'm working and what everyone's working, also the result.
Yeah, thank you very much. You do not worry. All of us do not work alone. Like what the IOC-WESTPAC team, you know, if you want to walk fast, you walk alone. But if you want to walk far, we have to walk together. That's our motto, you know. So you know, all of us have to work together. All right. Thank you for your what comments, you know. I would like to, okay, I'm seeing Prof. Tamasak here. Prof. Tamasak, there's a request. There's a request to invite you to speak. Prof. Tamasak. Prof. Tamasak. Are you here, Prof. Tamasak? Okay, if not, I think maybe Prof. Oh yeah, yes, Prof. Tamasak, yes.
I'm sorry.
Hello, how are you? Yeah.
Hello. Yeah, I'm fine. Thank you very much for.
We want to listen to you. You know what you feel the future should move toward, where we should move towards in the future.
Yeah, I just want to make a few comments. I think in terms of the policy, what the decision maker want to see is a clear picture of the impacts of OA. If you want to talk about the impact of OA on the coral reef or on the coral itself, you must have very clear scientific data to show that what is the impact of the OA on the corals or on the coral communities. And you have to convince them that the severe impacts will cause a lot of damage or a lot of economic loss, for example, and they will believe you and they will continue to support you. But if you can't do like that, it is impossible for the decision maker to support your idea or your research proposal. But for the OA, I think not only the coral reefs or the corals itself, we may focus on some organisms in the coral reef ecosystems or related marine ecosystems that we think those organisms or those ecosystems are quite clear, that we can show the clear impacts of OA to the decision makers. I think that is only my point to want to share with you now. Thank you very much.
Thank you, Prof. Tamasa. I think that is very true. The clear impacts, and also we must what we usually say, talk the language of the politicians. You know, you have to convert the science and the impacts into dollar and cents. The effect, the economy of the country. Then they will understand, and they would know that the scientists are serious, you know, in our work. Thank you very much for your comments, Prof. Tamasa, and it's really nice to meet you. Sorry, Wingzi, to keep you waiting. You know, I'm keeping the best for the last. Yeah. So I'm handing it over to you for your comments, Wingzi.
Thank you very much.
Sorry.
Yes, Malo. Sorry, Wingzi.
Before you conclude, may I just add something to what?
Yes, please. Yes, please.
Professor Tamasak said. I think the link should really be established. For instance, the impact of climate change on terrestrial crops is well established already. There's an empirical relationship between the increase in temperature and decline in crop production. So something like that, an empirical relationship between fishery production and pH change is something that we have to find. No, there should be a clear relationship. So if there's a pH decline of 0.1, then fishery production will decrease by this much percent. I think that's what we have to come up eventually. That's it. Thank you.
Thank you. Now, Wingzi, back to you.
Thank you very much, Eileen. First of all, thank you very much, all three speakers, for your very good presentation made today. I think this indeed reflects, the progress has been made after several years, I think, by the IOC-WESTPAC in the region to promote ocean acidification related monitoring and research. And I would also thank, Eileen, for your excellent moderation that you lead today. I think actually many questions you raised, provide very good, inspiring idea how to further define the future direction of ocean acidification related research and the impact for the region. So this, I think, a discussion today, particular at the last part, indeed reflect a very practical challenges that we need to further address. How to sustain our ocean acidification related research. Ocean acidification, the process and also impact is kind of a long-term slow process, right? It also coupled with other factors as well. High surface temperature, anthropogenic, particularly in the coastal area, impact on the coral reef issues. So this issue, after we establish the capacity that enable us to build some kind of a, baseline at a local level or national level. So how to further translate? I think still based on all the research I heard, at least, still it's a little bit too premature, I feel, to give some kind of a, certain impact or message to meet their policymaker or decision needs. So this is the challenge we are now, right? So I think many speakers reflected already. Yes, please link this, link links, but currently our capacity is not enough to link it. So in this kind of a context, how we can find a way to keep convincing decision maker or authority to put the investment on the ocean education. I think most of the projects so far done is very on ad hoc basis, right? And there's no long-term approach. So I understand the difficult for our most of research community in this region, very much ad hoc, you know. So even the number of paper issues, yes, the number of paper is not convincing enough. So we cannot also use the reason to convince policymaker, you should, because of limited paper, limited data, we need you to put money in research. This is chicken and egg and chicken questions, right? So this is the kind of things. So we have to find a way actually. So this kind of webinar serve kind of I think the mechanism to find the best approach for all research in this region, how we can sustain the ocean acidification related research monitoring in the long run, So many ideas actually today I heard from all of you. For instance, the ocean application cannot stand alone, right? To look at impact must be integrated with other factors as well, but also must be solution-oriented approach. For what, by what, to address what issues that we need this research. So this is something I think is quite a challenge. We always say, said easier than done. Particularly our research, I think over the last 100 years, always done in a very single disciplinary approach, very much lack of integrated approach. But the impact is always, the multi-stressor, based on, impact. So this is something we are also thinking how to do that, over the next 10 years in order to further improve the research capacity and also to generate more results to meet the different stakeholders, to demonstrate the power of science, particularly in this developing region. So there are kind of a lot of efforts ongoing, as Eileen mentioned. We're also thinking about the development of integrated program, even core reef oriented or pilot site oriented approach. So there's a many approach ongoing. So in that sense, I think we still need more ideas actually from all of you. For instance, whether, based on your experience and on your, network globally, international, locally, whether there's some kind of best practice you have seen, the ocean education has a clear, evident impact on some industry, on some ecosystem. This kind of best practice, I think is also very, very much needed for us to, to further, draw the attention of policymaker, decision maker in order to elevate their support to the ocean education related research. So if you have, please feel free to share those kind of practice. We are also seeking this kind of knowledge from the global network. Let them to show us whether there's some best practice, clearly showing the impact of the ocean education on some industry or some kind of ecosystem or organism, right? So this is the one best practice we very much needed. And the second, I think science still need to be inclusive. So any approach, good idea should be always welcome. There are a lot of work currently focused on coral reef. I think no wonder, because this is the coral reef is I think it's the most important ecosystem in Southeast Asia, and a lot of research work, conservation effort has been done. And also easily, actually this reflects the need and also the willingness to link the coral reef link the ocean education with the socioeconomic development, specifically on coral reef system. But in addition, we also need others. Like last time, from the first webinars, we're thinking about link this with the aquaculture, particularly mariculture, coastal and marine culture industry, and also we start to consider setting up our task force to review the literature, to network the people in the region, and also to have more impact analysis studies. But I think this is still far from enough. We need efforts at a different level, and also for different targets. So this is something I think we really wish to, building on the successful webinar that we had over the last 3 weeks. I think we still have 2 more, right? We still have two more. One more. Then we can, after the 4th webinar, if needed, we can organize one exclusive brainstorming session, brainstorm the way forward, how we can, as a UN body, as a group, how we can, find a way to sustain, to sustain the research and also its impact analysis in the long run. Either or focus on ocean education or integrated with other factors as well. So this is something very important. So all of you, I think, are working on the frontier, of the ocean-related research in the region. You show the responsibility actually to define the future of the research and also for the socioeconomic development in the region. So this is a responsibility that I think everyone has to bear. So thank you very much, Ellen. Once again, thank you very much for your very inspiring moderation today. And thank you very much, Apple, Tamsak, Patrick, and also Lynn, and all other speakers may know for your very, prominent suggestion, and also the excellent work has been done in the past. Thank you very much.
Thank you, Wingzi. Thank you for loading us with more responsibility. Yeah. I know, all of us hold great responsibility in making the ocean better and our future better. All of us are very thankful to IOC-WESTPAC for preparing this platform for us to get together, to discuss and to share the constraints and challenges we face, and knowing we are not alone addressing the issues ourselves. We need to continue to hold each other's hands and work together through multidisciplinary and transdisciplinary approaches towards addressing OA issues for the benefits of our ocean, right? Before I end the session, the time flies so fast. Before I end the session, I have one final request. Can all of you please on your video so the secretariat can have a group photo of all the happy faces today? And I really appreciate all the contribution and from the speakers. Yeah, Nachapa, we are all ready. You just count 1, 2, 3. Yeah, all right.
Okay. Yeah, please turn on the camera. Okay, are you ready? Let me take 1, 2, 3.
Okay.
Okay.
Done,
Okay,
right?
thank you.
Thank you very much.
Before I end the webinar series today, I would like to invite all of you to join IOC-WESTPAC again on the next Ocean Acidification series number 4, next Wednesday, same time, same place. I mean, same link, not the same place, but using the same link. And I would wish everyone to take care of yourself and stay safe. I'll pass you back to Somkiat to end the session. Somkiat, back to you. Thank you, everybody.
Thank you very much, Eileen, for your very excellent, moderator today, and thank you all participants as well. And then I hope that we are still looking forward for you to join us next week. and as well as to join our activity, WESTPAC activity, particularly, on the OA issue, that's like the Isla mentioned, I know that inform fishery is to be fishery also is one important part as well. We're looking forward, to integrate our work for ecosystem to the fishery. Thank you very much. See you again next week.
Okay. Thank you, Eileen.
Bye.
Thank you, Eileen, Ipo, Patrick.
Bye-bye, everybody. Stay safe.
Yeah, see you.
Thank you very much, Fancy.
Thank you, Apple. Thank you, Eileen. Thank you, Patrick.
Yeah, Eileen, congratulations for your new position. I just know.
Oh, thank you. More work. Thank you all, and please stay safe. Take care.
Take care.
Okay, take care. See you next time.
See you next week. Yeah, bye-bye.
Bye.
Bye.